Hello, my dear students. Today we are here to find the least common multiple of two or more numbers. So we are continuing under the lesson fractions. So we need to find the least common multiple in the latter part of this lesson. When we come across addition and subtraction of fraction, at there sometimes we need to consider common denominator when denominators of two or more fractions is not same. Okay, so don't worry about that now. That will be studied later in the chapter. Today we are studying how to find the least common multiple of two or more numbers. Okay, now what does least common multiple mean? Least common multiple mean the least possible multiple when we can list multiple for any number. We can list infinite number of multiples for any number. So when we list multiples for any number like that, so to find the least common multiple of two or three more or more numbers, you have to consider the common multiple first. Out of those common multiple, you are going to pick the least one. So that is called least common multiple. So don't worry if you are not clear about this now. We'll be discussing examples. See this example. Here we are trying to find the least common multiple of 2 and 3. I took 2 and 3 just to give the idea here. Okay, so we can find not only about 2 and 3 but even in big numbers. So let's first try to understand this. Here what I have done is I have listed the multiples of both 2 and 3. Now you should know what are multiples. Let me explain. Multiples are numbers like this. You can write 2 into 1 is 2. 2 multiplied by 1 is 2. 2 multiplied by 2 is 4. 2 multiplied by 3 is 6. 2 multiplied by 4 is 8. 2 multiplied by 5 is 10. So and so you can keep on writing multiples of 2. You can write infinite number of multiples. For 3, you can write 3 into 1 is 3. 3 multiplied by 1 is 3. 3 multiplied by 2 is 6. 3 multiplied by 3 is 9. 3 multiplied by 4 is 12. 3 multiplied by 5 is 15, and so on. So you can keep on writing infinite number of multiples for 3 also. So what I want to point out here is, can you see there are some common multiples which is common to both 2 and 3. Can you see in the both the list? Number 6 is there. You see, number 6 is there. So, and you may see 12 is also there. 12 is also common to both these lists. And 18 is also there. So, 6, 12, 8, and 18 are common to both the lists. Which means 6, 12, and 18 are common multiples for 2 and 3. But here, today we are trying to find the least common multiple. So least common multiple means out of these multiples, you need to pick the least one. So out of 6, 12, and 18, what is the least one? Definitely 6. So 6 is the least common multiple of 2 and 3. So this is just to give the example how to find least common multiple. We are having methods to find the least common multiple of not like simple numbers like 2 and 3, but even in big numbers, not only two numbers, but also for 3 or 4 more than four numbers. So let's see what are these methods. There are two methods in finding the least common multiple. They are using short dividing method and using prime factorization method. Okay, now let's see how to find the least common multiple of 12 and 18 using the short division method. Okay, this method is not hard, really easy, but you have to listen carefully, okay? Because there are some rules that you have to follow here to get the answer correctly. Now, what you should do first of all is you have to list the two numbers like this, separated by a comma, and draw a structure like this. Okay, draw some structure like this. Okay, and now what you should do is you have to think about the least possible number which divides any of these nicely. Okay, actually they are called prime numbers. Here you have to divide using prime numbers. So, okay, what are prime numbers? Prime numbers are numbers like 2, 3, 5, 7, 11, 13. Why they are called prime numbers? They are called prime numbers because they only get divided by themselves and 1. Okay, so we have to use those numbers here. But anyway, if you don't know about prime numbers, what you can do is think about the least possible number which divides any of these two nicely, which means there shouldn't be any remainders when they are divided. Okay, let's start with 2. Always check with 2 if any of these two numbers nicely get divided by 2. So, okay, you can clearly say 12 and 18 are both nicely divided by 2, right? When 12 is divided by 2, we don't have a remember, and answer is 6. When 18 is divided by 2, we don't have a remember again, and answer is 9. So let's write these answers here. Okay. Now what you have to do is, so if any of these two numbers nicely get divided, you have to write the answer. Okay. So that's the first rule of this method. If any of these two numbers nicely get divided, you have to divide it and write the answer. Okay, so let's continue using this method. Okay, now what you should do is you have to still think about 2. If any of these two numbers nicely get divided by 2. So is 6 nicely divisible by 2? Yes, 6 is nicely divisible by 2. But 9 is not divisible by 2. We have a remainder there. So even 9 is not nicely divisible by 2, but 6 is nicely divisible by 2. So you have to use 2 here then. So 6 divided by 2 is 3, and 9 is not nicely divisible by 2. So we are not going to make any change to it. Keep it as it is. And you have to continue the method. Okay, so what we can do here is now check whether we can divide any of these two numbers nicely by 2. Is 3 nicely divisible by 2? No, 3 is not nicely divisible by 2. 9 is also not nicely divisible by 2. So what you can do here is when 2 doesn't work, you have to think about the next number, actually next prime number. So the next number is 3. Is 3 nicely divisible by 3? Yes, definitely. 9 is also nicely divisible by 3. So the number that here you should use is 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. Okay, now there's another important rule. Once we divide like this, if we get a 1, you are not going to make any change to it. You are done with that part of the sum. You are only now going to think about the other number. Here other number is 3. So you are only going to divide the other number by the current or next prime number. So here, can we divide by 2? No, we can't. Can we divide by 3 then? Yes, we can. So you have to divide by 3. So you see, finally we have got 2 ones here. Whatever the sum, if there is 2 or more than 2 numbers, you have to divide until you get ones for all of these. Once you get ones for all of these, what you have to do is you have to find what you have to do to find the least count multiple is you have to multiply these numbers. You have to take the product of these numbers. Okay, let's take the product of these numbers. Least common multiple, I wrote it in the short form. In short form, for least common multiple, you can write LCM separated by dots. Okay, they should be separated by dots, and you can write LCM. So let's take the product of these numbers. 2 into 2 into 3 into 3. So 2 into 2 is 4. 4 into 3 is 12. 12 into 3 is 36. So that's how to find the least common multiple of 12 and 18. Even for any other number, you have to follow this method. Let's try another one. Okay, now we are going to find the least common multiple of 12 and 10. So what we have to do when we are going with the short division method is what we studied previously in the previous sum. So you have to do the same method. Okay, now what we should do first? We should first write the two numbers separated by a comma. Okay, so what's the next step? Next step is you have to use the least prime number. Okay, if you don't know about the prime number, don't worry, I'll explain it later. Go with the least possible number that any of these two numbers are nicely divisible. So here what it is, here can see that 12 and 10, 12 is nicely divisible by 2. So that's enough to use 2 here. Okay, so when 12 is divided by 2, answer is 6, and even 10 is nicely divisible by 2 here. So when 6, sorry, when 10 is nicely divisible by 2, answer is 5. So is 6 still divisible by 2? Yes, 6 is still divisible, nicely divisible by 2. So you have to still use 2. So 1 6 is divided by 2, answer is 3. Is 5 nicely divisible by 2? No, 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 no. 5 is not nicely divisible by 2. So we are not going to make any change to it. Keep it as it is. Okay. Now we need to think about the next prime number. Okay, because 3 is not anymore divided by nicely divisible by 2, and 5 is also not nicely divisible by 2. Anyway, 3 and 5 both are prime numbers. So prime numbers are not divisible by any other number. So you can't divide these with any other number other than themselves. So if you don't know about that, don't worry. Here, think about the next number that you can divide any of these nicely. So the next number is 3. Is 3 divisible by 3? Yes, definitely 3 is divisible by 3. So you have to use it. That's 1. And 5 is not divisible by 3. So keep 5 as it is. And now we have got 1 here. So we are not going to worry about that anymore. You have to only think about this 5 now. So what's the next number? Next number is 4 actually, but 4 is not a prime number. So we can't divide using that. Okay, so anyway, 5 is not divisible by 4, so we can rule it out. So the real reason that we are not using 4 is not a prime number. So the next number, that's 5. Yes, 5 is definitely divisible by 5. So we can use it. So we get 1 comma 1. And to find the least common multiple of these numbers, what we should do? We need to take the product of these numbers. So how to take the product? LCM. You need to multiply 2 into 2 into 3 into 5. 2 into 2 is 4. 4 into 3 is 12. 12 into 5 is 60. So you got the least common multiple of 12 and 10 here. So my dear student, this is the method of using short division. So there is other method called finding the least common multiple using prime factorization method. So we'll discuss that in our next video. So hope you understand everything nicely. So let's meet with another maths lesson. Thank you very much.